particles will actually take their orientation from the nearest face, and they'll take their speed value from the nearest face. And this can have the result that basically the particles will almost stick to the surface. It's not an absolute sticking to the surface effect though. So you can actually use this effect for when particles strike a wall or they strike an uneven surface, and then you can actually have the particles travel over the surface. But you have to be aware that the particles will actually wander away from the surface slightly. So it's not perfect in that respect. So if I press play, you can see now our particles are actually traveling over the surface. It's a little bit jittery because actually it's taking its their speed and their orientation from the nearest face. So, you know, depending on the tessellation of your object, that can actually be quite coarse, and that can cause quite large popping. So if we actually get the sphere here, and we go down to its tessellation values, and now if I press play, you'll see there's quite a big pop as each particle goes from face to face. And you can see it's actually quite jittery in some respects. It's not so much of an issue when particles are moving quite quickly, but if you want quite slow, smooth motion over a surface, then the best thing to do is actually to tessellate it a great deal, and that will actually allow the particles to travel in a smoother manner, as there's less of a difference between each face. Where obviously the more you tessellate the face value on the object, the slower the particle calculation will be, as it has to calculate more faces. So quite an interesting feature, but not without its problems. So let's go on to have a look at some of the other features again. We'll set speed back to set speed once, and we'll use surface normals. We'll go back to the beginning and we'll press play. And you can see there go the particles out at a steady rate. We can vary that value, as I said. I'll put in a value of 4.9 here, and that gives us a very large amount of variety. Some of the particles will hardly move now. Some of them will only have a speed value of 0.1. So if I press play, there you go. You can see some of the particles are basically left behind. They're not really getting much speed, and others are getting the full random range, you know, all the way up to basically 9.9. So they're traveling off much faster. So we've got the usual speed and the usual variation values here. I'll just get rid of the variation and put it back to the beginning. Now, if I show you shaded mode, you can see I've actually got a texture on the object, and it's this kind of chaotic color value that you have here. You can see I've got areas where there's pretty much black. You've got areas where there's red, there's green, there's blue. You've got some mixing going on in certain areas. And you can see I've used additive color, so in some areas we actually have white. We've got some white here, and we've got pretty much some white going on there. So we've got some white in certain places, and you can see there's a big band of white here. Now, we can actually use that texture on the surface to control the speed of our particles. This is very cool. This will actually work if it's animated as well. So if we have control speed continuously, we can cause our particles to decelerate and accelerate over time using an animated bitmap or an animated procedural texture. So that's very interesting. We'll turn off animated shape at the moment because we're not actually animating our shape, and we're not going to use an animated bitmap, but that is something that you can use, as I've just said. So there go our particles outwards, and they're heading out at a steady rate. So there's nothing really that interesting going on there. So what I'll do now is I'll just go back to the beginning, turn on speed by material, and it's using a grayscale multiplier. So, you know, we have a colored bitmap here. So how is it using that as a grayscale? Well, it's basically just converting those RGB values to a grayscale value. And if I press play, it's using white as the full effect. White areas will travel out at 5. And when it goes down to black, the speed will be 0. And obviously shades of grey in between those two values will vary the amount of acceleration, the amount of speed that we have. So if I press play, there you go. You can see now that you have the speed is based on the surface texture. And where the texture is the lightest, the particles are moving the quickest. So I'll just go back to the beginning here again. Now the next option down is sine grayscale. And what this actually does is it treats the relationship between black and white and 0 and 1, you know, as in 0 is no effect, 1 is full effect, in a different manner. What it does in this case is, instead of black being 0 and white being 1, white being full effect, black being no effect, what it does is it says 0 is minus half the effect, or rather minus the full effect, white is plus the full effect, and mid-grey is no effect at all. So our black areas will give our particles a negative speed, they'll travel backwards. Our white particles will get the full speed in the positive direction, and our grey areas will actually get no speed at all. So if I turn on wireframe mode and press play, there you go. So you can see some of our particles are heading inwards towards the center, some of our particles are heading outwards, and you can see some of our particles are hardly moving at all. They're obviously in areas where the color's very, very close to mid-gray. So we've got some options there for controlling speed. You know, this can be painted on as a bitmap, or this can be done procedurally, and as I said, it can also be animated. And when it's animated, make sure you turn on animated shape and you set speed continuously. So now we have two more options. These are a little bit more complex and probably very hard to use in reality, but they do give you a lot more control, and if you're in a particular circumstance where you want exact control over the speed and direction of your particles, then these two options will give that to you. What these actually do is they assign a direction and a speed value to your particles based on RGB. So red would be X, green would be Y, and Z would be blue. And in this case, it's using world space. Now, because we've got a pretty chaotic material on our material, this is actually going to produce quite a chaotic result in our particles. You can see they're basically flying off in pretty much random directions. It's not actually totally random. If I emitted quite a few more particles, if I change the birth amount here to say 2000, there we go, and if I press play, you can see that there is actually a pattern to the orientation of the particles and the direction that they're traveling in, and that is actually based on the material. So you can see that's pretty cool. I'll just go back to frame 0, and to make it a little bit clearer, I'll just change the scale of the particles so they're quite a bit smaller, so we can see that a bit more clearly. There we go. Now if I press play again, there you can see the particles are traveling off in various directions. Now don't forget again, you know, this value could be animated, so let's actually do that. I'll just put it back to frame 0. I'll turn off our particle flow for a second so we can animate our value. I'll go in here and you can see we're in the actual bitmap channel for this particular texture. And what I'll do is over time I'll animate it all the way up to frame 200. I'll use auto key here, and I'll change it so that there's an offset of 1 on the U-axis. So now if I scrub, you can see that the actual bitmap is rotating. This is by animating the U offset in the UV mapping. So there you go, particles are rotating around. Now you can see there's a pretty bad seam here, and that's just because I've been a little bit lazy. But you know, in Photoshop or whatever package it is, you could actually paint the bitmap so no actual seam appears there. And what this will actually cause is, at this particular point, any particles on this side of the seam will get quite a definite orientation, and the particles on the other side will get another orientation. So this will actually cause quite a weird result in our particles. But it's just to demonstrate, so this gives you a basic idea of how it works. So we'll just turn on our particles again, and they get populated into the scene. There we go. We'll press play. I'll select the speed by surface operator. There we go, and I'll press play. And you can see there go the particles. They're flying outwards as they did before. There's no real difference going on here. And you can see that this bitmap is actually animating. So we can see that our bitmap is actually animating, so I'll turn on wireframe just to make the display a little bit faster, and you can see how go our particles, and they're just following the orientation that they're initially given. There's no real change in it. So we'll just go back to the beginning again. We'll turn on animated shape, and we'll turn on control speed continuously. And now I'll actually press play again. There go the particles, and you can see it's actually much slower. Don't forget what particle flow is actually doing now is it's calculating the orientation and the speed of the particles based on a bitmap, and that's per integration step. So it's having to reevaluate those elements on an integration step to integration step basis. But what this is actually doing is this means that as the bitmap rotates around the sphere, it's actually controlling the speed and the orientation of the particles continuously. So as they fly through space, the particles are tracing a ray back to the surface. They're finding the texture on the surface at that point,